Okay, and we are on. Hi, everyone, and welcome to another edition of Hi Masterclass. This time for a really special masterclass with a really special guest. He is back after about like 2 years. Am I right, Alexandre?
Hello, everyone. Hello, João. Yeah, I think it's a bit more than 2 years, but
Okay,
yeah,
yeah, yeah.
guess who's back?
Yeah, he's back and he's back in full force. He is back to talk
Yeah,
about building a trip diagram with us. And yeah, before we start, and I'll let Alexandre do his thing, do his presentation, um, let me just say, as I do always, to drop us a like, follow our YouTube channel, and and share this content with everyone that you can. We would appreciate it very much. And if you have any type of question, please drop it on the comment section of this video, and me, Alexandre, or anyone at Interactive will reply to you as soon as possible. With that said, let's go to the presentation. Let's do it. And before Alexandre starts, you can have a full guide of this presentation that Alexandre is about to make on this QR code or on the link that will be on the description of this video. There you'll find like a full guide and a more complete guide on this presentation with more complete insights there. And yeah, with that said, Alexandre, let's start it. Let's do this
yeah,
masterclass.
yes, let's go.
Let's go.
So, okay, so we are going to talk about how to build a trip diagram with React technology and D3. They're basically the two libraries that React provides you like it's a front end library, and the D3 is like for interactive developments. You can build like a lot of charts, diagrams with it. There's a lot of things, cool visual things that you can build with it. And so let's start talking a bit about what is a trip diagram. So a trip diagram is also called a Mary chart. Um, it's basically a chart that has an x-axis where you can represent the time of the day. You have the y-axis where you have like the stations uh, along the route, and they are like ordered by a physical distance. And you have like these lines, and they represent like a trip. In case of, for example, train station, it would be like a one train journey going through those stations, considering time. Uh, and it is relevant because it provides like a highly visual, compact, and accurate representation of complex train schedules in case of a train chart. And it allows operators to immediately detect some conflicts. Uh, a static schedule diagram or train diagram won't provide you much opportunity uh, to understand everything. So we build here something that it's more like more interactive. You can zoom, you can scroll, you can hide some trips, and that will like take it out of just a simple chart and a static chart, and make it more like responsive. And yeah, we're building that. Actually, I can just show it right away. This is the, because I know everyone likes to see the end result at the beginning of the video. Right? Nobody wants to wait till the end. So basically, we have here this diagram. We have here several trips, and just showing kind of fast what you can do. You can basically just zoom this area, then you can scroll here with the scroll bar. You can even use the mouse wheel or the trackpad. So I can just go like up and down on my laptop trackpad, and I can scroll. You can go back with a double click. You can zoom as many times as you want, basically. So you can really dive deep into it and see how it responds. It responds very fast. This is a very simple scenario, of course. You can hide some trips. So if you don't want, if you are in a large data set where you have a lot of trips, here we just have 18, but you have like 200. This interactive design allows you to focus on what you want. And yeah, you can see that like the labels here is adapt. So the further you dive, now you're like in a half-hour scenario. If you at the beginning you're like 2 hours at a time, it spends like an entire day. And that is pretty much it. You have some tooltips around here, like for example, at 18 past 5, this first trip was at Riverside station. So you have this tooltip to give you this kind of information. If you over the line itself, you'll see that this is a trip that started at Central Station and finished at North End, and it took about 2 hours and 18 minutes. So yeah, basically this is what we built, and now we will talk a bit how we did it and some considerations that we have in terms of performance and other stuff. So first, as I said, this was built with React and D3, and like React owns the container lifecycle, so to mount, to unmount, and the D3 is going to own the SVG content, like with the drawing and interactions, and for that, giving some more technical perspective, we use two React hooks, and basically what we did was, okay, so React as the container, and now this part, D3 is going to handle it. So everything that's around the diagram itself, it's being taken into care by the 3D library. So like we just provided a DOM node. Okay, D3, you have this DOM node, and here it's where you'll do like your magic. So, and to build this kind of chart, or any kind, you have to think a little bit about the data modeling. So how are you going to represent? So your data model will facilitate the way you will represent and the performance of your application. So in this case, we have a station structure. Very simple thing. It's just a list of stations, and then taking in consideration the trains or the trips structure, it's a little bit more complex, but it doesn't have much things. You just have like the train ID, so like trip number 1, trip number 2, which is like each of the lines that we see here. Like this is 7, this is 6, and they have a code that helps distinguish. And you can, of course, you can. This is just a simple example, but you can have, for example, several trips with the same color if in your situation it applies. And then you have the stops. So a trip will have several stops. Like for example, this one, it's stopped in each of the stations. So it's like a regular trip, and you have there the time in which that train stopped at that station. And then we have here the value, like for the 480, which is the minutes from midnight. So this was kind of trying to simplify the way to represent the time. So instead of using a date object, and anybody that works with development knows that date object, it will be harder to process, harder to work with. So sometimes you have to take into consideration these kind of things and just try to simplify. So like 8 a.m. since the beginning of the day, instead of having a date object, I can just say it's for 80 minutes. It will make calculations much easier. You just have to multiply the number of minutes in each hour, like 60 times 8, and you have the 480. And it will reduce some complexity on your application. And then you have the order of the stops, and they basically define the direction and the movement in the diagram. If you see like here, so this one, it started from central station, and as it was like going this direction down, this one started here and then finished here. So you can see the direction, and also you can see with the lines, you can also see like the speed. If something takes a lot of time, it's a slower trip, but if something just goes like this with a very small declive, it's a faster train. So yeah, this to say that the way you model your data will impact the calculations that you have to do. Basically, when you like are zooming and scrolling, you are modifying it. So if you have a simpler data model, it will make your application more fluid. It will respond better. You won't have to like, as you can see, like here, as soon as I scroll, it behaves. It's fast. You don't see any like loading scenario. You see that the result really goes by with the scroll. And now we will talk a little bit about the scales and the layout. So basically, like to keep the visualization like clean and readable, we reserve some space around the edge for axis labels and some contextual information that you can add as well. Like in this case, we had to reserve some space here for these labels. So the chart itself, the diagram starts like here. We have a linear time scale. It is basically time here is represented as a continuous horizontal axis, and it spans the full 24 hours of a single day. And by using this simple linear mapping, between the time and the space, we ensure several things, such as the proportions are accurate, speed difference are visually meaningful, so you can really understand the speed of a train, and also the zooming and the panning that was showing, it feels just natural. Then you have some scale point for stations, and basically they are just discrete stops along a route. So they are positioned, in this case, we positioned evenly along the vertical axis. So we have all of them with the same distance. But if you want, in a more complex scenario, probably all of these stations are not like 2 kilometers away from each other. One is like 1 kilometer, or there's 2. So in that case, you would need a more complex data model, and instead of just an array of labels, which is this scenario, you can say, okay, you can work with some proportions. Say like this from this one is 10, now it's 20, 30. But if it would be 35, it would be like here more in the middle. So you would have to take that into consideration. But in this case, just to keep it simple, we built it just like this. And then you have the clip path uses, and it's basically to keep the visualization like clean when you are zooming and panning. We are restricting the drawing part or area of the visible chart to this box, and anything that's outside of that box, it's hidden. For example, here, this line, if we can see, there's more line than this, but the box here just like cut it off, because you are in the, you don't want it to overflow and have a line here. You want to have like a box that really represents the timeline that you have here. So if you want to see it, you have to scroll, and everything is like inside of this box. You're not seeing stuff like overflowing and getting on the top of the screen or something like that. So this was the considerations that we need to take for like the scales and the layout. And then about the rendering, and because we render the chart here like we chose for this presentation a deterministic redraw, which means that every time I am, for example, I'm here and I do this, I just cleared everything and I replaced. I didn't track, okay, I need to change this line, and like the first one I don't need because it's not here. No, we are redrawing everything based on the current data and the visible time range. So now I'm only interested in a little bit before 9 till 6 p.m. Till 4 p.m. Sorry. Um, and we could consider some transitions, but we didn't go for it. Although D3 provides some powerful transition capabilities, those transitions will require updating multiple elements individually and synchronizing those transitions. It will just provide some more complexity here, but there's the option, but we didn't go for it just for this presentation. Also, another common approach would be to have an incremental mutation, so only modifying attributes instead of rebuilding the whole chart, but that would be for maybe for a larger data set of another example. Like here it's just 18 trips. It does not justify. We try to keep something simple, but then that would be a concern, like for some performance reasoning. At this scale we have like what, 100 maybe 200 SVG elements. So a full redraw is effectively instantaneous. As you can see, as soon as you do it, it responds very fast. But if you want something more complex, we will talk, like I think it's 2 slides further, about some performance reasoning, and we'll give some tips on what we can do. And that is like for when you would change the structure. Like if you have a data set that is bigger, or even if it's not bigger, but you just think, okay, this, but maybe next month I will have like 10 times, 100 times this. So if you want to try to think about it in a scalable way, we would need to rethink this approach, and we will dive a little bit on that. So, but before those performance ideas, I want to talk a little bit about the interaction engineer. And here we have, I split into 3 topics, and the first is the layering as an event system. And basically, we are working in the SVG, which are scalable vector graphics, and basically their visual stack, their visual stacking order determines how the interactions behave. So like an element that is rendered later, or like it's below on another element on the HTML DOM, it will appear on top, and they are the first to receive the mouse events. This to say that the structure of the SVG directly controls how the over, drag, and zoom interactions are parameterized, and we try to take that into our advantage. For example, we have here, go back to the diagram. For example, every time I'm not above a line, I have this like this point allows me to drag and zoom. But if I am above a line, I don't have that option. I have now I'm like in a tooltip mode, so I'm in a layer that I just over it, and I see some stuff appearing on the tooltip, and this is possible because uh, this event is on an element that is after the event that's on the after the element that has this event. So this takes priority because it's further down on the SVG uh, on the HTML SVG on the DOM. But for example, if I'm like doing this, and if I hit here, I have the tooltip because this one is like is below on the is after on the page, so it captures the is the first to receive the element. So this to say that if you are dealing with SVG, the order of the elements is very important. An element that appears after will take the event for that area. Then we have some invisible hit areas, and like these lines that we have here, they are very thin. So and I think they are visually very clean, but sometimes they can difficult to hover, to just pass the mouse on top of it. So in order to improve the usability, we had some invisible interaction layers on top of this visible paths, and these are wider and they are transparent, but they capture the event without changing the appearance of the chart. Like you don't see, but there's an invisible line there that improves the accessibility, the user experience, but it also like preserves the visual clarity and makes just hovering easier and more comfortable in general. And then you have the tooltips, and you can do it like two ways. Basically, you can use like a text node in SVG, but you also can just create an HTML element, which was what we've done here, because it provides rich formatting, it's flexible styling, and it's more clean. Here, for example, in this scenario where when I'm hovering like this circle here, we have like three lines in there. So in order just to break the line, you would need like two text in SVG, and in HTML you don't need that much. And also you can just have each it's easier to style it. Like here you have three different text colors, and that would be a bit harder to do with the SVG. So okay, let's go back to the presentation. And if we keep going, okay, zooming and panning, I think I already showed much of it, but we have the Birch X mechanics, which is basically the user goes here, you just select an area, and the name of the event, you just birch into that area. And when we make this selection, we convert the selected pixels into time values. So that's why you have the chart updated like this. And once you are zoomed in, you have, like I showed before, you have like this scroll bar appearing. You can just scroll through it, or you can just go up and down. I'm doing it with the mouse wheel, or you can just use the trackpad. And all these interaction methods, they are synchronized to a single source of truth. Like it's there's only one state. You don't have, okay, when I zoomed it was like this, when I scroll like that. No, you're updating the same internal time range, and it facilitates because you only have one source of truth. Okay, I think I already showed much of it, but just always going back and forth with the application and the presentation. But okay, let's not take too much time. But I want to talk a bit performance and scaling considerations. I think this is a very important topic. And okay, so what can we do if we have a larger data set? Basically, we use SVG, but and SVG it provides a clear structure, inspectable elements. It has built-in support for over interaction. So when I just uh, uh, just go over the tooltips. But if the data set grows, or if you think it's going to grow, you can change to Canvas. Canvas, it renders directly to pixels instead of creating individual DOM nodes, and you have much more performance that way. Although at some cost of more manual interaction handling. But if you have a huge data set, like Canvas would be the way to go. Definitely, the performance would be much better. Then we have the virtualization strategy. So okay, you can go to Canvas, and you can also go with this strategy, and it is basically rendering every element at all times. It's a necessary. So a strategy like this, a virtualization strategy, it focuses only on what is currently visible. For example, here I don't see trip 10, 11. So every time I scroll, do I need to redraw them? Do I need to take them into consideration? No, I don't, because they are not visible. But once I reach them, now I need to see trip 10. Now I don't need to see trip 1. So you can just focus on the ones that are really on the screen. And then you have web workers, which is basically a background thread that executes on the background. It's like me asking another person, okay, can you do this for me? And that person, then I just don't have to think about that person will do, and then will provide me the result. So you just, if you have preprocess, if you need to preprocess some large data set, filter, detect some conflicts, you can just move that into a web. Your application won't be stuck until it waits, so it's not blocking. And when that worker is done, it will provide you the response, and it just make it easier on your performance. And then you also have the option to go for some incremental updates instead of a full redraw. And at this current scale, this is simple, this is reliable, and it's instantaneous. But at larger scales, incremental updates may be preferable. So instead of rebuilding everything, you just update the elements that change. So you can just try to understand, oh, only this line changed, that one didn't even change, so I don't need to update that one. So yeah, these are some of the examples that you have to take in consideration for performance. And yeah, let's just go through some conclusions, and we are almost finishing. And okay, so the pattern behind this solution is reusable. This is not just for a trip diagram of a train station. You can use this for other things like project timeline. You can build a chart with time and instead of stations, other labels, monitoring, logistics. meaning like they are going to benefit from this same like architectural principle. And basically the key takeaway from this is like effective data visualization is not just about rendering chips. We are not just, oh, it's I just put some lines there on the chart. It's it is about designing a state interaction structure in a way that remains robust even as complexity grows, or as you have to scale into a more complex situation. And if you treat these interactive visualization as engineered systems rather than some isolated components, we can build solutions that are not only like visual compelling, but scalable, they're maintainable, they're adaptable. And so in the future, just it's easier uh, for you to change, to add more features, to keep improving, to solve bugs, and to attend to some of like your client needs. And I think it's pretty much it. I think I've covered some important topics. And just move here to the chart a bit. But
You sure
yeah,
did. You sure did, Alexandre. Yeah. So as I said in the beginning, I said that Alexandre was coming back in full force, and he has proved it to
I
all of you.
tried.
Yeah, and yeah, be sure to check Alexandre's article. You will get everything that he was saying here on this presentation on our blog article at our website. And yeah, as I said in the beginning, if you have any type of question, please drop it on the comment section of this video. Drop us a like, subscribe to our YouTube channel. Thanks to the ones at home that stood by till the end and really got all of the insights that Alexandre has brought us. Thank you, Alexandre, for this great presentation. And yeah, with that said, let's get that thumbnail photo. Uh, and yeah, with that said, thank you everyone, and see you on the next one. Bye bye. Thank you.
Okay, thank you guys. Bye.